Okay, so I just started the recording. Welcome everyone. I think we should start. The people who will be late, well, will watch the recording. Okay, so let me share my screen. And can you please confirm if you can see it?
Yeah, we can see it.
Okay,
Yes,
awesome.
it's
Awesome.
it's
Okay.
visible.
Okay, fantastic. Okay, so welcome everyone. I'm Anna. I'm the lead organizer of Hack-4-SAGES hackathon. And today we are kicking it off with our welcome webinar. The whole webinar is recorded, so don't worry if you miss part of it or if you miss the whole thing. It will be recorded and it will be uh, posted on our social media. It will be also posted on Slack, and we will share all the slides with you as well. We will try to share them right after the webinar. So this is the agenda for today. So we will first do the introduction, then we will talk to you about the schedule, and at the end we will do a Q&A session. After that, that's my part, and after that we will have a welcome lecture by Dr. Antonin Affholder. So let me introduce us. So I'm Anna. You can see me on the slide, but I obviously am not the only person organizing this hackathon. So it's 6 of us who are organizing it. We are PhD students and bachelor master students at 4 different universities in Poland and in Switzerland. And you probably saw you probably interacted with some of us via email or on Slack, but there are also some people working in the background that you may have not met previously. So that's us. And I just want to start this webinar by saying congratulations to all of you. I think you are really doing great already. We have read all your projects and they are very impressive and they all seem very interesting, and we are sure that you will do great during this event. So we wanted to give you some maybe brief statistics about the applications. So we received 194 we had 194 applicants across 5 continents. So considering that this is the first time we are organizing this hackathon, I think it's a pretty decent result. We we have accepted 52 teams, and the numbers of the teams in each category are presented on the screen. So I know that there was one question in the Google form that we sent to you about the number of teams in each of the category. So the number of teams in these categories are not even, because we had significantly more applications in the exoplanet habitability category. So that's basically the reason why the numbers are not even, but we decided to go with this, basically not having the even number of teams in different categories to give as many people as possible a chance to participate. So now I will talk to you about the schedule of the hackathon. You can see it on the screen, and I have also, I think Lucia has send it to you via email. So please, please, please read our emails because all the information is there. But I will briefly talk about the schedule for all the days. So today is not really officially the hackathon yet. The hackathon will start at midnight, UTC +1 time zone. That's what I'm talking about. Whenever I give you time, it's in this time zone. So please, 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 the first thing is you need to check the times in your time zone, but I'm talking about the UTC +1 time. So today is a day when we have the welcome webinar that we're doing now. And also today you get the first chance to meet your mentors. So we have sent you emails with your mentors with their availability. And you were supposed to book a 1 hour slot on each day of the hackathon with your mentor, and then communicate it with the mentor, and then meet with your mentor on every day of the hackathon, including today. So we know that some of you didn't do that, and it's not good. So please do it as soon as possible, as soon as you can, because the mentors are waiting for you. And today you are supposed to have an introductory meeting with your mentors. So that's the plan for today. And as I said, the hackathon officially will start at midnight tonight at midnight. And then during each of 3 days of the hackathon, we will have 3 meetings. So we will have 2 1-hour live Q&A sessions, and we will also have something that we call daily check. So let me briefly explain to you what it means. So every day during the Q&A session, you will have an opportunity to ask questions to me directly or to anybody else who's going to do it, but it will probably be me. And to access this meeting, you basically need to use the same meeting link as you're using now. And these sessions are not recorded. So now the welcome webinar and the winner announcement, these two meetings will be recorded. But the live Q&A sessions and the live daily checks will not be recorded. And this is a chance for you to chat with us, to clear out any doubts, to basically ask us questions. This is the Q&A session, and then the live daily check will be a short half-an-hour meeting every day, during which we will summarize all the things that maybe were unclear, but we're either asked the questions that were either asked during the Q&A or in chats. And it will be just a very quick meeting where we will summarize anything that happened on that day and clear out any doubts. So none of these meetings are compulsory. You don't have to attend these meetings. However, we do suggest that you at least attend the daily check if it's possible for you. Obviously, we want you to sleep as well. Although it's a hackathon, we want you to sleep as much as you can. But we do suggest that if you can, you attend the live daily check, because we'll try to, again, summarize everything that happened on that day and clear out any doubts. So that's how the 3 days will look, essentially. And then on midnight on 12 March is the submission deadline. And this is very, very, very important that you check what that time is for you in your time zone. Because if you don't submit your projects by the deadline, unfortunately, you will be excluded from the hackathon, and we really don't want that to happen. After the submission deadline, on 13th March, the jury will be grading you, will be judging your projects. And then at 7 p.m. our time, we will announce the winners live. If you cannot attend that meeting, which we totally understand because it will be very, very late for some of you, don't worry. First of all, the meeting will be recorded. And second of all, we will contact the winners directly via email, probably towards the end of next week. So don't worry, but obviously we suggest that you attend. I mean, everybody's curious who wins, right? Okay, now regarding the mentorship. You probably received a couple of emails from us regarding the mentorship. So the mentors are available for you 1 hour each day starting today. So from today till Thursday, you have access to your mentor 1 hour per day. And this is a great opportunity, and we suggest that you use it. But remember that you are the person responsible for communicating with your mentor. So what you have to do is, first of all, read our email, because everything is explained there. If you don't understand something, please ask us on Slack. Essentially, what you have to do is you need to create, first of all, select a time slot when your mentor is available and no other team has already booked it. And then create a Slack group chat with all your team members and with your mentor to inform your mentor about your selection and then to meet. We have also sent you Google Meet links via email, and we suggest that you use them. And also what I want to say here is shout out to all our awesome mentors. I really wish that I had pictures of all of them and I could have them on a slide here, but unfortunately we don't have their pictures. So I just want to say thank you to all the awesome mentors who are volunteering to help you with your projects. I already talked about this, but just a quick reminder, you do not need to attend the live Q&A sessions or the live daily checks, but they are optional, but we suggest that you at least attend the the live daily check-ins, just to have an idea of what is basically going on, if there are any pending things that you should know or do. But also you are always encouraged to ask questions via your designated Slack channel. So please, please, please do not ask questions on the general channel. If you're a participant, you have your channel for participants. If you're a judge or a mentor, a co-host, you also have your designated channel. So please ask your questions there. You can also obviously message us directly, but I think it's easier if you ask it on the designated channel, because then all of us can see it, not just one person. Regarding the project submission, we have already been asked about it many, many times. So here I'm explaining it. If you join later, don't worry, we will send you the slides, and also this meeting is being recorded. So you will have access to all of that. So the submission works like this. You will have to produce a video that you will have to post on YouTube, and make sure that this video is not set to private, because we will not be able to see it. This video can be maximum 2 minutes long. And this is very important that you follow whatever is mentioned on this slide, because if you do not meet the criteria, that the requirements that we are mentioning here, you unfortunately will be excluded from the competition. So I understand that this can be tough. This might seem tough to describe your amazing, amazing projects in only 2 minutes. But unfortunately, we have so many teams that it will be impossible for judges to review all your projects properly if your videos will be longer. That's why we decided to ask you to make these videos 2 minutes long at maximum. After making this video and putting it on YouTube, you must submit the link via Google Form. And remember that it's midnight from 12th to 13th March, UTC +1 time. Again, I want to highlight it. Please, please, please make sure you know what time it is in your time zone, because all of you are in totally different time zones. So it's very hard for us to check it all for you. Please check it for yourself and make sure you have the right time saved. Only one person should submit this form, just like when you were registering, only the team leader, or however you want to call that person. One person from your team was submitting the registration, and here the story is the same. Only one person should submit the results. Another important thing is that you must provide us all the names and email addresses of all your teammates. And we already asked for that in the registration form, but some of you still use your private email addresses. This time, we unfortunately cannot accept that, because we need to be sure that all of you are students. So please use your university email addresses. If you don't have university email address, which, I mean, we can imagine that maybe you have this situation, please, please, please reach out to us now as soon as possible, so that we are sure that this issue is resolved and that we understand your specific situation, because otherwise, unfortunately, you will be excluded from the competition after submission. So we obviously don't want that to happen again. Another thing that I want to mention here is that the winners will also have to provide us official proof of being a bachelor/undergraduate student. We need that to, again, confirm that you are bachelor students, because this competition is only designated for bachelor students, so we want it to be very fair. Yeah, so this is important. This slide is very important, okay? Regarding the judging criteria, obviously, I know it's a lot on this slide, so I will not go through all of this, but we try to be very open about the judging criteria. We have shared them with, obviously, with the judges, but also we have shared them with your mentors. So maybe some of your mentors have also shared them with you, but we are also sharing them with you directly. So there are 7 main categories in which you will be judged. So the fit to the selected competition track, meaning your category that you selected in which you're competing, whether it be the origins of life, the biosignatures and life detection, or the exoplanet habitability. Then also the relevance to the broader astrobiology field, the originality of your project, obviously the use of the digital technologies or digital twins technologies, right? That's also kind of important for us. The academic maturity and your problem-solving skills, reproducibility of your project, as well as the quality of your presentation, so the quality of the video. Here I want to thank all our judges. You can read more about our judges on our website, but I just want to give a quick shout out and quick thank you to all of them because they will have quite a lot of work on Friday to go through all your projects. So I just wanted to mention them here briefly. Regarding the awards, I think all of you more or less know what the award is. The award obviously is an invitation to Switzerland. You'll be invited to present your projects at the Origins Federation Conference Early Career Day, which is happening in September. I believe it's 7th September, but we will communicate it with the winners via email again next week, probably towards the end of the week, closer to Friday. So we will, that's not the only thing. Obviously, there's a whole trip to Switzerland, visit to ETH, etc. included. Additionally, we'll have time during the summer to improve your projects, to receive some additional mentorship, to again make the projects a little bit more sophisticated, I guess, a little bit more ready to present them at the Early Career Day. Additionally, you will have networking seminars with experts in the field. Probably some of these experts are present here, but at this meeting. But yeah, you will get this opportunity to have meetings with some experts in astrobiology, astrophysics. So I think this will be a pretty cool opportunity for you, considering you're all very early in your careers. So I hope that this will be also useful for you. Yes, so we will again communicate all the details next week. Now regarding the questions, please put your questions in the chat now in Zoom, and I will now go through some questions that we received via the Google form that we sent you a few days ago. So this question, actually, we received it earlier. This is one of the questions that we received before our info session, but I decided to include it here because I think not all of you attended our info session. So we really want to, bring this slide into your attention. So the question is, what can be used and what cannot be used? So we generally try to make this a very realistic science project for you. We don't want to put additional unnecessary constraints on you. And because of that, we allow you to use whatever is public, like public data sets, published models, or existing frameworks. And I guess this question was mostly about ChatGPT. So we do allow you to use ChatGPT. Obviously, we cannot prohibit you from using ChatGPT since it's a hybrid hackathon. We cannot, look at your screens, and we really do not want to do things like that. However, remember that we can also use ChatGPT, and we can see when something is purely ChatGPT, and I'm sure the judges can see that as well. So be mindful about that. ChatGPT is a tool. It's not your teammate. It's not your mentor. It's not your something that will do the project for you. So please be mindful about it. What you cannot use, on the other hand, is proprietary or restricted data without permission. So if, for example, your mentor or whoever gives you access to their data and explicitly tells you, yes, you can use it for this project, go for it. But if you do not have permission like that, please do not use it. This is really not legal, and this is really not okay, and this is not something that we will accept. Additionally, you cannot copy results, somebody else's results, maybe from a paper, and present them to us as something new, as something that you did. You cannot steal somebody else's ideas. We are really not okay with that. And with that, I think we can go to the next question, which we received now before this welcome webinar. And the question is the following. Could you please confirm if participants retain full 100% ownership of their code and ideas? And to that, I say 100% yes. These are your projects, these are your ideas, and we do not claim any ownership over them, obviously. However, we do ask you to grant us free access to the videos that you produce. So if there is something that you do not want to share publicly, please do not include it in the videos, because we will be publishing the videos of the winners and the honorable mentions. So in total, 9 teams on our social media channels. So please remember about that. And in fact, in the Google form, you do have to click that you select that you give us permission to post your videos on our social media. We will not be editing your videos in any way, but we will be posting them. Okay, another question. My team had chosen to participate in person, and therefore we would have in-person meetings with our mentor. However, from what I understood in one of the emails, our meetings will actually be held virtually via Google Meet. Could you please confirm this for me? Okay, so we were matching you with your mentors based on your project and your mentor's expertise. We were not matching you based on your location. Obviously, we tried to make sure that you are in comparable time zones, but still, this was not the priority for us. The priority was that your mentor's expertise and your project match. So in most cases, you are not matched with a mentor who is maybe even in your country, you know. Oftentimes you are matched with a mentor who's based in another country, definitely not at your university. However, we do have cases where the participants are matched with mentors who are in their university. So if that is the case for you, then it's actually on you to navigate with your mentor. You can ask your mentor if they are happy to meet with you in person at your university, and that's totally fine by us. But this is not something that we can arrange for you. You need to do that by yourself. And another thing here is that remember that the official language of this event is English. So please, unless you're 100% sure that your mentor speaks another language, do not send them emails in not in English. So please try to communicate to your mentors in English unless you're sure that they can speak your another language. Another question: can we meet with our mentor?
Actually, I just wanted to add, if it's okay,
Yeah.
to the previous question, because it is true that all of you have received a Google Meet link, regardless of whether it is possible for you to meet with your mentor in person. So yes, just like Anya said, please navigate that with your mentor. We just all wanted to provide all of you the opportunity that no matter what happens, even if if something does not work out, you can still meet with your mentor online. But yes, you can, of course, please check in with your mentor. The mentor knows and they have received in an email if it's possible for them to meet with a team in person. So they will let you know about that. Okay, so please just check in with them, and yeah, and if anything happens, if you are expecting to do it in person, you still have the Google Meet link and it will work. So that's from us.
Yeah, and if you have any issues connecting to your mentor, or if you are a mentor and you have issues connecting to your team, please let us know, because it's very important that you start meeting regularly from tomorrow onwards. Okay, another question that we received is, can we meet with our mentor other days than Monday? Absolutely. We actually want you to meet with your mentors every day during the hackathon. So unfortunately, there was some misunderstanding with some of you, and you thought that you are only supposed to meet with your mentor today. Absolutely not. This is fake news. You are supposed to meet with your mentor every day if you want to, but if you don't want to, then please tell your mentor that you don't want to meet with them, because they're waiting for you. So please, please, please read our emails, because all the information is there. So yes, you can, and you are in fact supposed to meet with your mentor every day during the hackathon. Another question: how to get connected to your mentor? So clearly the mentorship thing is a bit confusing. So let me reiterate that you are supposed to select 1 hour time slot on each of the hackathon days. We send you when to meet links. And in these links, you can find your mentor's availability. Please only select the time when your mentor is available and when no other team has booked that time slot. Because we had mentors who had 2 teams booked at the same time. That's not okay. That's not allowed. So every team gets their own time with the mentor. No, double team meetings. After that, after you select your time slot, please create a Slack group chat with your teammates and with your mentor, and inform your mentor about the time slots that you selected, and then meet with your mentor on each of these days. Because we also had cases of teams not arriving, not making it to the meeting. So that is also not okay because the mentors are waiting for you and they are there for you. And please respect their time. Thank you very much. Yes, so remember also to check your time zones and your mentor time zones. And whenever you communicate with your mentor, tell them this is my time zone because oftentimes you are in different time zone than your mentor. So that's important. Okay, good luck. And I'm wondering if we have any questions. Okay, I see we have some questions, so let me quickly answer to them. So my university email ID did not get activated. Unfortunately, I can't use my university email ID. Okay, Shreya, please, please contact us directly. Send us ideally an email to me or to Lucia. Send us an email and we will navigate that with you. Okay, if there are questions, another question. If there are questions allowed from the chat, what classifies as digital twin technology in the judging criteria? So if we go back, we explained in the info session what a digital twin is. So if you're confused about this concept, please go to our YouTube channel and watch the info session. We explain what is a digital twin. We explain what is astrobiology. We explain what is digital twin and astrobiology. So essentially here we will, I mean, again, it's up to judges. I'm not a judge, but the judges will basically evaluate whether you have applied digital twin technology in your project. Is there something that again is like a representation of a physical phenomena or of a physical object or whatever? I'm not sure what your project is about specifically, but is there something that is like a representation of a physical phenomenon that you coded, for example? So this is what you will be judged based upon. I'm not sure if that's clear, but if it's not, please write another text in the chat. Okay, the next question is what to include in the video? Only the PowerPoint of results / code? Do we need to record our voices or just the images, screen recordings? So this is up to you, honestly. This is up to you. All your projects are very different, so you know best how to present your project to the judges, how to show how you use the digital twin technologies, how to show the whatever project that you're working on, whatever problem you're trying to solve. Do you think it's making a demo of your code? Do you think it's just making a presentation? Do you think it's, I don't know, singing a song? I mean, probably not, but whatever it is that you feel like is the best way to present your project to the judges, to persuade them that your project is best and you deserve to come to Switzerland to present it, then this is the way that you can do it. And we don't want to constrain you in that. It's really up to you, as long as it's 2 minutes long. I know that it's very short, but unfortunately we had to do it this way. Okay. The final question, do we have to show ourselves in the video submissions and does it have to be submitted on our university accounts? So the first question, no, you do not have to show yourself in your video submission. Absolutely not. If you want to, go for it. It's great. People will see you. We'll be able to connect a face to the project, but there's no need to do that. Remember that these videos will be posted on our YouTube channels and shared on other social media channels. So if you don't feel comfortable showing your face or if you don't feel comfortable sharing your voice, then that is okay. Do it the way that you feel comfortable and that you feel like is the best way to present your project. And the final question is... Are you saying something, Zita?
No, sorry.
Okay, sure. And the final question is, does it have to be submitted on our university accounts? It doesn't matter from which account you submit it, but in the Google form, you must give us your email address, your university email address. And that is the important part because we need to confirm that you're actually a student. The reason why we're doing that is because we had some submissions from people who were clearly not university students, and we must confirm that you are university students. Okay, so okay, another question. What is considered an undergraduate student? Undergraduate student is a student who is pursuing undergraduate degree. So a bachelor student, for example. Sophia, are you a bachelor student? I think you're from Portugal, right? I'm not sure if I remember correctly. Yes. Okay. So you're a bachelor student, so don't worry about that. You are undergraduate student. You count. You're good to go. Okay. So I think we're classification in Portugal is different. We okay. Okay, please send us maybe a message in Slack so that we can. Okay, please send us Slack messages to sort out this situation, because now I'm honestly not sure and I don't want to take other people's time, and I'm actually over time. Okay, cool. Yeah, so great. Once again, good luck to all of you. And now I would like to start. I would like to introduce our speaker on our welcome lecture, Dr. Antonin Affholder. So Dr. Affholder, his alma mater is and I cannot read that, but it's the École Normale Supérieure Paris. I'm sorry, I butchered that. He's currently a novice ETH fellow at the Center for Origin and Prevalence of Life at ETH Zurich in Switzerland. He's an astrobiologist working on habitability and biosignatures, and he's an expert in model development. So he developed models for the atypical microbial ecosystems, which may have dominated the biosphere of Earth's young years and now populate the oxygenless deep oceans and soil. Okay, so I will stop sharing my screen. The floor is yours, and welcome again.
Thank you for the nice introduction. Let me just share my screen. Oop. Okay, can we make sure that you see the actual presentation and not the presenter mode?
Yes.
Okay, great. All right, let's go then. Well, thank you, Anna, for the nice presentation, and thank you for giving me the opportunity to introduce this exciting week and talk about digital twins in astrobiology. I will preface this by saying that my talk in no way will, be a legal basis for the definition of digital twins when it comes to this hackathon. It's just my own interpretation of what I think about when I read the digital twins stuff, and how I think I've employed this kind of methods in my research. I will start by talking about why we might want to use those methods, a little bit of how we can do that, and very specifically how I did use digital twins in my own research. And hopefully I will stay within 20 minutes. And I will start with talking a little bit about the history of the Earth, which is the only planet that we know has life and has had life in the past. Even if there is weak evidence or clues that maybe Mars had life in the past, so far there's no definitive evidence of that. Earth remains to this day the only planet that we know has life and has had life. And if we look at this nice spiral here, I don't know if you see my pointer. Hopefully you do.
We can see it.
Okay.
I can see it.
So if we look at this spiral that represents, the different geological times of the Earth. So we sit in the present, so right at the edge here, and we live in this planet where the atmosphere is composed of O2. We have those nice temperatures, etc. And if we want to go back in time, we dig up rocks and we look at fossils, and we use this fossil record to learn about the past history of the Earth. Except fossils they just exist for this, essentially this blue era here, where we have animals big enough to leave fossils. This blue era here is about 500 million years long, half a billion years long. We have evidence that life originated maybe 3.8, 4 billion years ago. So that leaves out this huge stretch of time, 3.3, 3.5 billion years of a planet that has life, but that, this life leaves essentially no physical trace in sediments and rocks. We don't have fossils for that life. We know that this life is likely not composed in majority by animals or macroscopic organisms, but mostly very simple single-celled organisms for essentially all of this time period. Even more striking is that for a fair bit of the Earth's, for the existence of the biosphere on Earth, there was no oxygen on the atmosphere, or much less than we have today. Oxygen started to accumulate to much lower levels than today, but still some noticeable levels. We think about 2.4 billion years ago, so that's around here. And we have still this long stretch of time, more than a billion years, where life exists, but there's no oxygen in the atmosphere. Not only there's no oxygen, but for some of it, there's most likely not even photosynthesis. So the way these very early ecosystems are supported has to be very different from the way that modern ecosystems are supported, that is by production of organic matter from photosynthesis. So all of that to say that a lot of life in Earth's past is essentially alien to us, very, very different, inhabits a planet that is super different from the planet that we inhabit today. And we have a very sparse record of this. And there's many, many questions that arise about how this sequence got to unfold, what were the causes that led suddenly oxygen to accumulate, for example, in the first step, and then in the second step. All of these things remain big and open questions in the history of life on Earth. And of course, one of the biggest questions is at the very start here, how did it start at all? Today, we don't see any occurrence of life emergence happening when we look at even geysers or the ocean. But life did occur, did emerge on the planet at some point. And this happened at a time where we have zero geological record of it. So we can't go back in time, and we don't have much to look for in rocks and in the geological records. So many of those big mysteries in Earth's past remain very inaccessible to us. What we can do is do a little bit of space exploration. That allows us to some extent, go back in time a little bit. I want to highlight here some exciting and very new results from asteroid sample return missions. Asteroids, they're rocks floating in space, and they're thought to have evolved very little compared to the original solar system material that composed the Earth in the early days. So their composition informs us on what could have been the stuff that was present on the early Earth just after accretion, just after it got made out of floating rocks, essentially. And these recent results, they highlight that essentially all of the molecular components of life are present in those early materials. They found all of the canonical nucleobases, so those are, ATGC from DNA as well as uracil from RNA. They found sugars, including ribose, which is how you get those bases to stick together into DNA or RNA. They found amino acids, so those are the basic bricks of proteins. So that stuff is there from the start that we know. And of course, we also see these molecules in other places, not only asteroids, but also comets, also even protosolar nebulas that we explore, that we observe far away from the sun. So those components are there, but we just don't know how they get together in making life, because in the solar system we don't find life so far. We can also look at our sister planets. So the only two other planets in the solar system that are roughly equivalent to the Earth if you look at them from afar, right? Mars and Venus, they're both rocky planets. Mars, Venus, and Earth, they all form and they all, orbit the sun in this narrow sort of region where you can imagine at some points, possibly in the past, liquid water might have been stable on the surface when it comes to temperature conditions. And indeed, from Mars, we have evidence that liquid water was flowing at some point in the past. Here I have a satellite picture of flowing, well, fossils, or they're now dry, but like canyons, dry canyons, evidence for past flowing water, sort of rivers. But now Mars is totally frozen. We don't see extant life. So we might wonder what happens between early days of Mars, when maybe it was looking a little bit like the Earth, and today when it looks so different. Similar questions can be raised by exploring Venus, which is very similar to the Earth in many aspects, has a very similar mass. But now it's totally hellish place with very high temperatures, very dense atmosphere. We don't think the surface, at least, can have extant life. So yeah, that raises questions about how planets take different path in their history, right? This kind of concept is sometimes referred to as dynamic habitability. So that's how, globally speaking, planetary environments evolve under various feedback processes. So that's more about the geodynamics, the geophysics of a planet. Here I have a very famous graph for astrobiologists, which is the birth, essentially, of what we call the habitable zone concept. So this stretch of distance from the star and mass of the star, where the equilibrium temperature of a planet can tolerate or is compatible with stable liquid water at the surface. This changes with time, because the sun changes luminosity, but it also assumes dynamic processes existing at the surface of the planet. The assumption of the habitable zone, sometimes we forget about this, but the assumption of the habitable zone is that within this window of luminosities that is received by the planet, there are some thermostat processes that maintain CO2 levels in the atmosphere in such a way that the greenhouse effect sustains liquid water at the surface. This process is assumed to be something called the carbonate silicate weathering cycle. And we might and one of the big questions is whether this process can be sustained on planets, whether it was sustained or stopped on, for example, Mars and possibly Venus. And the reason for this is that we think that this process requires something like plate tectonics to occur, right? Because that allows fresh material to be resurfaced regularly and to provide new rocks to be weathered and power this. I don't want to go too much into details, but all of this is to say that one very important component of habitability is not just where a planet is around its star or whether the ingredients are there in the start, but it's also about the presence of, or the existence of, processes that exist through time and that dynamically contribute to shaping the habitability of the planet. It's also nicely illustrated by this graph here from this 2015 paper, where the authors speculate that life could be also one of these processes that contributes to shaping habitability globally, and that perhaps this could have been, or this could be, rather, let me rephrase. They speculate that whether life evolves the capacity to contribute to these feedbacks can be a bottleneck to the sustained habitability and sustained existence of life on the planet. For example, if we find traces of past life on Mars, extinct life on Mars, that could be consistent with this kind of hypothesis where life could have emerged, in a way hinting at the fact that life emergence might not be a bottleneck in the prevalence of life, but maybe life then evolving the processes to feed back onto its global conditions, being more of a bottleneck where maybe Earth by chance had those and maybe Mars did not. Those are some of kind of big ideas about this, but of course now we only have in the solar system, we only have Mars and Venus to compare our situation to. And so that's where, exoplanet science comes into play, is that by now we have more than 6,000 detected exoplanets. And we hope that looking at these planets can take, planet science into a new level where we have a much larger sample size and much deeper understanding of the diversity of planets and the diversity of the trajectories that they take in time. And, for example, we can already look at, with the current capacities that we have for observing, we have this scatter plots of planets' orbit radius on the x-axis, and on the y-axis their mass. So that's a subset of planets detected for which we have the mass. And not only that, but also the diameter of those dots, the circles in the graph, this diameter scales with the planet's radius. So those are only planets for which we know radius and mass. So not 6,000, but much fewer. And so we can have an idea of the distribution of this, these different classes of planet. One big discovery or, big thing that came out of this is what they call this radius valley here, where there's an apparent, lack of planets that have intermediate mass between much larger planets and what we call super Earth. So those are the planets that have a radius slightly bigger than the Earth. And so we're starting only now to have this sort of bestiary or zoo of planets and understand a little bit how population of planets are structured. The next step of that, of course, is to try to constrain how we can test hypotheses about emergence of life or sustained habitability on these planets using large samples of exoplanets. For example, we have this paper here from 2025 from a colleague of mine where they found that, if we can find, those are big ifs, but if we can find like 50 planets with life and we can assess that they have life, then maybe we can say something about whether or not UV flux is an important contributor to emergence of life chemistry. Here we also have this work from 2021, other colleagues, Alex and Daniel, where they constrain how many exoplanets should we probe to get a sense of whether planets with life tend to develop O2 in their atmosphere or not. And you can see that those can be pretty large numbers, up to 300. Here I'm showcasing a little work of mine where we look at how many planets should we look at, how many atmospheres of exoplanets, of Earth-like exoplanets should we look at in order to get a better sense of how prevalent are these processes that I was mentioning a little bit earlier, that sustain temperate conditions on the surface. So that's the carbonate silicate weathering cycle. So we found that with 25 we can get by. So we have these exploratory studies that look at can we actually test stuff about emergence of life or long-term habitability or habitable conditions at all using this new gold rush of exoplanet science that's permitted by all of these exoplanet detections. The problem is, of course, that for now our capabilities to look at exoplanets are still very limited. If you look back at this scatter plot I showed a couple of slides earlier, Earth has, orbit radius of 1 AU and a planetary mass of 1 Earth mass, of course. So that's within this red circle. We know 0 planets in that circle. We don't know about a single Earth-like planets. Sometimes we tend to forget that, but 6,000 exoplanets, and we have no means of detecting an Earth-like planet, a truly Earth-like planet. So yeah, and we just, for now, we just can't know because we don't have the instruments for it. Maybe next year we have this European mission that's gonna look for their existence and locate them, but we're still far away from probing their atmosphere and characterizing the surface conditions, right? For example, here I'm showing a recent spectrum from the atmosphere or at least the emission spectrum from the presumed atmosphere of exoplanet TRAPPIST-1b, I believe, you see only 2 points on this spectrum, okay? And we can't say much. Actually, this article is like, maybe it can be bare rock at the surface, or maybe it can be a pure CO2 atmosphere. We have no way of actually knowing with the observations that we have now. And so future telescopes, we're trying, to discuss how we can design them, etc. But it will take decades before they fly and before they contribute to exoplanet science. So we are in this era where we have a little bit of a problem, right? We can do a lot of things with solar system science. We can do a bunch of things with exoplanet science, but we still don't have access to the juicy things, right? We don't have access to biosignatures on Earth-like planets. We don't have access at all on the atmosphere of Earth-like planets, and we don't have other planets in the solar system that help us too much well, I mean, they do help, but they're still pretty limited to explore them and to look for life on them. And that's why, of course, we use models. Perhaps you would call that digital twins. I'm recalling here this casting paper about the habitable zone. Of course, that is a concept that relies on on the model of this carbonate silicate weathering cycle existing at the surface of the planets. So that's one use of the models, creating concepts that help us guide our search. Now we look for planets that are within this so-called habitable zone. That's one, big check mark that we can put on exoplanet detections, and it helps us also think about what habitability means, etc. We also need models. Sometimes we tend to forget that, but we need models to interpret the atmospheric spectra of exoplanets. This is a much richer spectrum than the one I showed. This is for a much bigger planet with a much thicker atmosphere. That's K218b. So it has a lot more data points, right? But in order to understand how these data points give us the atmospheric composition, we still need to run models. We still need to model the physics of the atmosphere, the chemistry of the atmosphere, and then try to match the outputs of those models to the data. And that's how we get a sense of what can be there in the atmosphere. Other uses, but I'm running out of time almost. I'll go quickly. As I mentioned, we can also use models to try to estimate what are observational requirements to solve questions. I was showcasing origin of life questions. Here I'm recalling these results from my own paper from last year about the existence of this carbon cycle, geological carbon cycle. So we can use models also to inform strategies for observations. And one use of models that I particularly like is we can use models to isolate processes, represent them in a much simpler way. We're not trying to reproduce exactly reality, but we're trying to isolate processes and understand how they might work together. All right. Here I'm showing the results of two papers I was part of. In this left side, we show how the evolution might be super tiny on your screens, but essentially we show how the evolution of early ecosystems on Earth may have warmed Earth at the time where it could have been very cold because the sun was much fainter. And then we show how evolution of other metabolisms can disrupt this. So we show this kind of dual contribution of early ecosystems into feedbacks of the early Earth's climates. So, that means that there might not be a very fundamental way that the biosphere interacts with its global conditions, but it might be very contextual. And on the right-hand side, to hammer this point even more, we show how on Mars, the evolution of the same ecosystem that was warming the early Earth would have instead probably cooled down Mars quite significantly, actually triggering global glaciation. So, we can use these models to try to get a better sense of how one process might participate in one way under a certain context and how under a different context, something else might happen. I wanted to go a little bit more in depth into one use of digital twins or models that I've had to work with in the past. That was to tackle the habitability of Enceladus. Very briefly, Enceladus is thought to have hydrothermal vents potentially. And then we wanted to try to see whether the composition of that plume that was sampled by the Cassini mission could inform us on whether or not those hydrothermal vents could be habitable or even contain microbes. To do that, we needed to produce synthetic data, as I was mentioning before, synthetic data of the plume and try to compare that with the observations. So in essence here, the synthetic data would be fluxes of CH4, methane, and H2. I forgot the x-axis label here, I'm sorry. In the plume, and we needed a model to translate broader hypotheses into this synthetic data. And one thing that was particularly tricky, to me at least, it was to try to model the hydrothermal vent. A hydrothermal vent is actually quite a complex environment. It's very messy. It has lots of mineral precipitating. You can see it has several chimneys, etc. We can't do that, one-to-one scale and one-to-one all of the processes in a model. So I had to find a smart way to isolate, what was a relevant feature of the hydrothermal vent when it comes to the question that we had here, which was about simulating the overall fluxes of matter into the hydrothermal environment and then out into space where we could measure. And to do that, I designed a very simple physics model, mixing the waters and then assuming that they were rising up due to buoyancy because they're warmer than their environments. And that was one way where I actually, totally simplified the hydrothermal vent into a simple gradient of temperature that's physically sound, but that's not physically realistic. What's my point for this? I just wanted to, say that, of course, one last step of this, modeling pipeline is then you cannot really use the outputs of these models as you would use the outputs of an experiment, right? Because we're not looking at the real world here. We're just modeling. So then when we have comparison of our model outputs with the data, we have to go back to our premise and then ask how we have, or maybe, and then consider whether we now have a new look into those premises now that we have taken those premises into some extreme and produced some predictions and then compared with data. That was my point here. And I just want to finish in a few seconds with a point that I think is important here, is that there is no model that is going to be one-to-one real life. All right, we cannot possibly model every process that exists. And I think that's also probably pointless. Models will always lack features of the real world. I think a good comparison of what is a model to a scientist, to science, is a little bit like what is an android to a human. Androids, for now, they exist only in the cinema, and they're a tool for the filmmakers to make us think about what a human is. The androids, they're a simulation of a human, but they're not a human. They cannot be a human because otherwise they would be a human and not an android. And I think that's a little bit like what a digital twin is. A digital twin is not an exact copy of reality in a computer. It is an android that makes us think about what makes the real world in comparison with our simplified, very dumbed down version of a few processes working together. So models are useful to ask questions, create explanatory frameworks, but we have to remind ourselves at all times that they are not a copy of the real world, and models do not tell us actual things from the real world. And with that, I will finish here. Thank you.
Thank you so much. Let me stop the recording now.